Thank you very much. Appreciate that. So just to give you a little bit of background about myself, I'm one of the members of the Shardis team. And Shardis is basically working on building the foundational technology that we're going to need for global scale applications. So what do we mean by global scale applications? You know, when the internet first started out, you know, we didn't imagine that the killer app for it would be like social networks, right? I mean, I remember I was having a hard time getting coworkers at NASA to put up a photo on their homepage, and now, you know, we do that without thinking and give our information to so many different sites. So how this space is going to evolve in the next 5 to 10 years, we can't hardly even imagine right now. But one of the things for sure is that it is going to grow, and this is not a fad, and it's not going away. And we have to start planning for the day when there are, you know, billions of daily active users all participating and interacting on the same blockchain or distributed ledger. And those kind of systems are going to need millions of transactions per second. You know, some simple global scale applications that you can imagine is something like a global currency. I mean, imagine if there was a currency that everybody in the world was using. So you'd have billions of people using it. Another application is, you know, a global identity network. If, you know, we kind of think that over the long term, identities based on reputation and endorsements will actually be harder to fake and become more valuable than government issued identities over time. And once that happens, then, you know, even governments will become consumers of that kind of a system. And so it would be great if the whole world was on one, you know, global identity network. And that way everybody can plug into that public utility. Another application would be like a global communication network. You know, right now, all our communication is you know, through various different silos. You know, you might have WhatsApp or LinkedIn or Telegram, but if your friend is on another platform, you know, you can't really communicate until you or him, you know, get the other platform. So imagine a global communication network. So these are kind of applications that, you know, we imagine will be coming in the future, and we really need to think about how would we be able to handle those kind of applications. So we got into this thinking about how to build a platform like this because we actually wanted to do something like a you know, a globally traded electronic coin, and we've been thinking about this since like 2011, and thinking about, you know, a platform to implement this on. And we were pretty excited when Ethereum came out, and thought maybe we could do it on that, but, you know, soon realized that it just doesn't have the scalability to be able to handle these kind of applications. And, you know, another application that we were thinking about is Globalville, which is, you know, an identity system based on Web of Trust and reputation, and it's, you know, community issued identities. And once you have that, you can also use that same platform for a communication layer. So these are, you know, applications that we've been thinking about since, you know, 2011, and how to implement these, and not finding a platform to do it. And so eventually in 2016, we just said, well, somebody's got to build it, right? So that's how we got into building Shardis. So the current issues that we have now with our existing platforms for, you know, doing decentralized applications, some of them are, you know, very power hungry. You know, you kind of need that for consensus and increasing security. But, you know, evolution always selects systems that can do the same thing but with more efficiency. And so my long-term view on systems that are doing, you know, mining and using a lot of energy is that, you know, if another system competes and is able to perform that same level of, you know, capabilities and do it more efficiently, then it's more sustainable and will probably win out in the long run. Now, you always have, you know, the whole network effect countering that, but, you know, we'll see how it goes. But you'd like to have systems that are more, you know, efficient. Another issue is that, you know, we don't have a lot of scalability in the current systems. And by scaling, you really can't use the word scaling unless your system can actually make use of the resources given to that system. And we don't currently have our systems doing that. We're also barely decentralized. A lot of the big systems out there are getting to the point where a few entities have a majority of the control. And you can't really just measure decentralization based on how many nodes you have participating in the network. You also have to think about, well, how many actual different unrelated parties are contributing to that network, right? So if you don't have a lot of unrelated parties, then you lose that decentralization. So I'm going to go through each of those issues and, you know, kind of address them. And so first one is, can we do consensus more efficiently? Well, yeah, I mean, you know, there's been classical consensus algorithms that have existed since the 1980s. You know, like Paxos, the paper for that was written in 1989. There's RAF, PBFT, more recently Tendermint. So all these systems can do consensus efficiently, but it's consensus among a well-known group of nodes. So Bitcoin's biggest contribution was allowing us to do consensus when we didn't know who all was participating in the consensus. So it was a permissionless system. Anybody could join at any time and leave at any time. And you didn't know who all the other nodes were. You maybe only knew about a few of them. So, you know, maintaining that is very important when you go to building systems that are going to be used for public utilities. So, you know, if you look to nature, there is consensus going on all the time in biology. So there's a phenomena in population biology referred to as genetic drift. And essentially what happens is if there's multiple characteristics in a population, over time, even without any selection criteria applied, even with just random selection, you will lose the initial diversity that you had, and your whole population will become identical. And so, you know, that's a phenomena that happens, and you can look at that as consensus, right? So you had like 2 transactions, and over time, after some iterations, the system selects 1 transaction. So I actually encountered that back in 1995 when I was working on my master's thesis, and we were applying genetic algorithms for evolving recurrent neural networks. And we would start off with, you know, a randomly created pool of neural networks, each one represented by a bit string, and evolve them using these genetic operators. And we found that even if we didn't apply any type of a selection criteria, our population was losing its diversity, and every bit would, you know, eventually converge to one value or the other. And we actually had to add like a mutation operator that would just randomly go in and flip a bit, to keep that level of diversity going. And so since I had done this, I kind of knew about, this phenomena, and I thought, well, can we bring this back and apply it? And and so we came up with this consensus algorithm I refer to as drift consensus, where essentially you have a bunch of nodes which are kind of doing the same thing, where they query other nodes to find out what transaction those nodes are going with, and then update their output in terms of what transaction they're going to support based on what the majority is supporting. And you can actually get consensus quite fast, and the system can be unbounded. You don't have to know about every single other node in the system. So in 2011, about 6 months after running into Bitcoin, I recognized that we could do this, but there was other issues, that this wasn't enough. You still needed to solve the scaling problem. And so we started asking the question of how can you make the networks more scalable? And if you want true scaling, you have to do two types of scaling. It's not just transaction throughput that scales, but you also have to think about your data storage capacity, and you have to scale on that dimension as well. And as I said before, you're not scaling unless adding more nodes to your network allows you to achieve greater capacities. If you say, well, our network is very scalable because we can do 10,000 transactions per second, well, what are you going to do when your application hits 10,000 transactions per second? Are you going to add more nodes and up that capacity? Well, if you can't add more nodes and up that capacity, then your system really isn't scalable. It just has some fixed threshold at which it can run. So we have to think about designing systems from the very beginning which have the ability to scale. And the key technology that's been used in distributed systems to do scaling is sharding. And it's been used in the database world for decades, and we haven't really applied it very aggressively in the blockchain or distributed ledger world yet. But that's something that can be applied to build systems that are more scalable. And as I said, you have to think about scaling both the transaction and compute, as well as scaling the data storage needs. And if you're not doing both of those, then you're eventually going to run into a situation where your nodes are going to need a lot of data storage capacity and not be able to keep up. So for example, Ethereum is talking about doing sharding, but they're only doing transactional sharding. And so every node still needs to hold all of the data. And once the amount of data that a node needs to hold continues to grow, it's going to be very hard for individuals to run a full node. You're going to need to run a system that has maybe exabytes of data capacity. And so it's not really decentralized then, right? So so it's very important to keep both of those aspects or dimensions in mind when you're thinking about scaling. And one of the challenges to scaling is, how do you communicate information like, well, we've had consensus in this shard, but now we need to let other shards know about it. So that's always a challenge. And in systems that are blockchain based, and where the finality of a transaction having been accepted is probabilistic, it adds a lot of delay before you can actually go and tell another shard that, hey, we've accepted this transaction in the first shard. So you want to have systems where the finality is much faster. And you can get that by having systems where within a shard, it's a bounded group of nodes that are making that decision. And so you can achieve faster finality by using algorithms that are more similar to the classical consensus algorithms. And as we design these systems, we have to be very careful about making sure that we keep our systems decentralized, because you could start off with a system that is decentralized, but over time it ends up becoming more and more centralized and loses that decentralized nature. So to really have true decentralization, you really have to have many unrelated parties that can be anonymous and don't know about the other parties that are participating in the consensus. If you have a scenario where all the parties know who's involved, you lose a lot of decentralization because of that. You're trusting sort of your data and this ability to approve and disapprove transactions to a group of people, and they can collude very easily if they wanted to. And also, having more node does not just outright guarantee more decentralization. It increases the probability that you have more decentralization, but you still have to make sure that those parties are unrelated. And maintaining anonymity in who's participating in the network is also very important. If your nodes cannot do that, then you really can't say that your system is decentralized. But once you do that, there's also a trade-off against like getting Sybil attacks. So if you let anybody be able to join your network rapidly and participate in it, then your network becomes more open to Sybil attack, and you have to hope that there's a lot of people already participating to ensure that your network doesn't get like a 51% attack. So we're keeping all of these things in mind as we design our system. And one of the things that you can do to incentivize decentralization is you want to try to attract individuals to participate in your network as opposed to businesses. And in order to do that, you need to keep your resource requirements very low. And that means, somebody should be able to use like a VPS server with, maybe one CPU and, 1 or 2 gigabytes of memory and maybe 100 gigabytes of hard drive space, and participate in your network and contribute those resources to your network. And you have to design your network so that you maximally utilize those resources that are contributed and can, grow your throughput and your storage capacities using every node. So keeping, your resource requirements low is very important. And also, the way you reward the participants for contributing to your system is very important. And right now we're doing it based on mining, where a particular participant gets lucky and suddenly receives a lot of tokens for that. But that leads to participants trying to pool their resources to get a steady income. So that's already somewhat flawed. And so over long term, if you design a system where you have this huge variance in your payout, the participants are going to try do something to try to reduce that variance in payout. And when they try to figure out how to do that, they're eventually going to eliminate some of that decentralization that you could have achieved by having so many participants in your system. So having regular payouts is more important. Your participant should be guaranteed to get some reward on a periodic basis, as opposed to having to compete with each other And it shouldn't matter whether you have 10 nodes in the network or 10,000 nodes in the network. They should each be getting the same kind of payout on a daily basis. And you want to keep the amount of reward that they're getting kind of low, so that you're attracting people who are more like hobbyists to your network, as opposed to people who want to make a business out of doing this. So that means you want to try to keep the margins low so that it's not attractive for a business, but yet hobbyists will do it because, hey, at least I'm making some money, And so that's the kind of incentives you need to sort of set up with your network in order to achieve greater decentralization. So, it's Shardis. We've created this project, as I mentioned, because we didn't see anybody else doing it, and we were hoping somebody would do it so that we didn't have to. But in the space, we always say that, hey, if you want something done, do it yourself, right? So we wanted to really get this made so that we can build the applications that we're planning to build later, but we needed that technology. So we have a team of 15 developers, 6 of them in Dallas, and 10 of them worldwide. We have a community manager and 5 advisors, and our software is going to be open source once it's released, but currently we're developing it sort of closed source. And we contemplated that, and we ended up deciding to do it that way because just of the way things are right now. Protecting your ideas is kind of difficult, and it's very easy for somebody to take something that somebody else has done and just hype it, and we're not doing like a hyped ICO or anything like that. I'll talk about that more later. We just want to keep our noses down and build this technology, and it would be very easy for somebody to just copy our white papers and pretend like they invented this technology. And the other aspect of it is that there's a lot of big players out there that are applying for blockchain-based patents, and if they found out about how we're doing things, it would be very easy for them to patent the same technology, and that could that could backfire, and you'd end up in a situation where you couldn't necessarily use the technology that you invented because they were first to file. So we do plan to patent our technology, and basically we're going to use our patents defensively, and it helps to show that the technology is something that is worth patenting. And we invite anybody that's interested in learning about what we're doing and really checking out the project to come and visit us, and you can check out everything, even our code, by signing an NDA. And I'm going to talk a little bit about our token and how it works, but before doing that, I just want to throw out a disclaimer that anything that I'm saying here is not intended to be financial advice or investment advice, and you really should do your own due diligence, and any decisions that you make are your own decisions. So having said that, so we have a ERC20 token that's out there, and we are using the tokens to give it to our developers using a rate of 10 cents each. And what do you need this token for? So the way it'll work is that once the Shardis technology is built, public utilities that want to use that technology can license it. The way they would do it is they would just use the Shardis software, and then whatever project they build, will being a public project, will necessarily have some sort of a coin or token on it. And so we just ask that they give a small percentage of their token or coin back to the Shardis token holders. And it's, you know, a win-win situation. It helps the Shardis token holders who supported the technology development early on to receive sort of, you know, like a payout from these other projects that are going to use the technology. And it helps those projects gain a community of users right away for their project. In a way, it's a little bit like, you know, what happens with Ethereum airdrops and, you know, with EOS airdrops. So it's that kind of model. And then for enterprise use, we basically require that the enterprise purchase some amount of Shardis tokens and then send it to our contract, which has a purchase license function on it. And that function will burn those tokens and send you a license token. And so, you know, you can prove to the world on the Ethereum blockchain that, hey, I've purchased a license for the Shardis software. And, you know, we're not going to go after a company if they don't do that, but we feel that, you know, the cost of obtaining a license versus the reputation that they would lose by not obtaining that license is, you know, it's more valuable for them to actually get a license. And so that's, you know, kind of the model that we're taking. And once we've developed the technology, we're going to create our own coin using that technology, and that'll be able to showcase and demonstrate to the world that you can actually build an application with this. And, you know, the simplest application to build is a payment network with the coin. But we plan to add a lot more features to that coin, and not just a simple transfer. You know, we've learned a lot from all the different coin projects that have happened, and so we know that, you know, having a maintenance fund and having, you know, community governance is important for a coin. And like I said, we haven't done any ICOs, and, you know, anybody can participate in the project to receive the tokens, and, you know, that sets up the incentives much better, you know, and it also saves us a lot of time from having to deal with how are we going to raise funds and what do we do with all this excess funds that we raised, and you know, you don't have to deal with those kind of issues. We have what I call Justintime Capital, you know, so if you can convince people that your project is worthwhile and they're willing to accept your token, then your token is the value, right? So you don't have to first convert it to something and then use that as the value. And our roadmap basically is that this past quarter, we've demonstrated the Shardis consensus algorithm, and we ran it on a global AWS network. And we've proven that next quarter, we're going to build what we refer to as the Shardis Enterprise Server. And essentially that just has one shard, and it basically works only with simple transactions. So a simple transaction is one where the source is just one account as opposed to like multiple accounts spending in order to do that transaction. So we're shooting to get like, you know, 500 TPS with that single shard. And then the quarter after that, we're going to build our Shardis global server, and that one will have multiple shards, and that will allow us to be able to do linear scaling, and we're trying to shoot for, you know, 20 transactions per second per node. So as you add more nodes, the network will scale and be able to handle more transaction throughput as well as storage capacity. And then beyond that, we're going to build the Shardis Universal Server, which is multiple shards but complex transactions, so that you can have multiple source accounts, you know, so you can say spend from A, B, and C and send that to, you know, some account D. So that will allow more general type of transactions to be done. And once the technology has been built, then we're going to focus on building the Liberdis network, which is, as I mentioned earlier, is a coin to showcase the Shardis technology. And we have other projects beyond this. So after Liberdis is done, we plan to do a smart contract system using the Shardis technology as the engine. And then beyond that, we plan to do like Getcoin and Globalville. So the future of blockchain is very bright. This is definitely a technology that can change the world and make it a better place for everyone. We expect large-scale applications to come up in next 3 to 5 years, and we're still very early in this space. It's like we just invented the calculator, and everybody wants to start writing games and word processors on it, and the appetite for building applications on this technology is so great. But the technology will evolve, and it'll happen. So thank you all for coming. And if you have any questions, I can maybe take one question, because it looks like we're kind of getting short on time. Yes?
How many nodes per shard, and does that affect performance?
How many nodes per shard?
And does that impact performance?
So as I mentioned, well, actually didn't mention, but I had it up there. I got to go forward to our roadmap. So we're shooting for like 20 nodes per shard. So there's trade-off between, as you reduce the number of nodes, you lose the decentralization. It's maybe gets a little bit easier.
If you have more nodes, the performance slows down.
No, it actually increases.
I mean, in a shard, in a single shard.
Right. And so
Find the optimal number of nodes.
Yeah. You're right. So it slows down a little bit, because now you have to do cross-shard communication, and each node sort of has to know about all the other shards that are out there. So it's not as big of a hit, but it is a little bit slower than a single shard. Yeah. So we're shooting for getting like 20 transactions per second per node. And so if you had 1,000 nodes participating in your network, you would be at 20,000 transactions per second. And if you had a really global network and needed millions of transactions per second, if you get to 100,000 nodes joining your network, and if nodes can do it with low resources, you can hit those kind of numbers, and you'd be at 2 million transactions per second. So
How close are you to proving that, what you just said, that you can actually get 2 million in that many shards?
So that's coming up in the next couple of quarters, and whether we are able to build a technology to prove that out, we'll see. But I mean, my background has been in building distributed systems for large enterprises, and I've built a lot of like mission critical systems, and I've used sharding a lot in the systems that I've built. So I do see this being able to achieve those kind of numbers. Thank you very much. I appreciate it.